Hey guys, in this lesson we're covering work done, okay? Hopefully you remember there's a really important formula for work done and we're going to review that in this video. I'm going to give you some examples that you might see in your exam. And don't forget there's always my resources if you want extra revision and if you want to join our live lessons, the link is in the description. So, work done. First thing you need to know is what's the unit. Hope you're thinking, if I do work, we are using energy. So work done is always measured in the unit of joules. Okay, so remember capital J is for our joules, Joules. It's our unit for work done. There's an equation for work done, and it's going to get given to you on your formula sheet, but it's really helpful if you remember it, right? Because if you remember it, you're going to be faster in your exam, you'll have more time to review. So if I want to know what work done is, how I remember it is that weekends are FIFA days. So I don't know if you're really into FIFA, that football game, or weekends are football days. But what you want to remember is W clearly stands for work done, which we just said is measured in joules, capital J. F, hopefully you all know what's measured. F is for force. Forces, we know after Sir Isaac Newton, is always measured in newtons with a capital N. Do not write a lowercase n. And D stands for distances. In distances, we always measure in meters, okay? So weekends are FIFA days. Work done is force times by distance. Because remember, when they're beside each other, it means that we multiply. The extra thing you know about this equation is that the work done, to calculate the work done, is the force times the distance in the parallel direction. So remember, what we're saying here is they have to be in the parallel direction. So what does that mean? So parallel lines, they obviously run parallel to each other. They obviously run in the same way as each other, okay? So what we're saying is whatever force we're looking at needs to be in the same direction or the same line as whatever distance we're traveling. Maybe that's 2 meters, okay? It's in the same line. So those would be the work done is force times distance because they're parallel to each other. Or let's say the force was in this direction, the distance I use then must be also in that same line, so like 1 meter. So they're 2 parallel lines to each other, okay? So let's say we want to calculate the work done. So let's say we've got a box, and let's say that box is pulled by a force of 2 newtons, and it's going to be pulled a distance of 3 meters. So if I want to calculate the work done, what we're going to do is work done in my test. I write my equation, force times distance. I put my number in for force, which I already know is measured in newtons. That's number 2. We multiply by a number for distance, which in this case is 3, and we get a number of 6 joules, right? Because work done is always measured in joules. 2 3 is 6. Okay, another one could be, let's say we have a box here. Let's say, again, that we know the box is moved with a force of 5 newtons, and let's say that it's moved a distance of 2 centimeters. Okay, so hopefully first thing you're thinking, warning, they give me a unit conversion, right? If I want to do that unit conversion, I think, what is a centimeter? So there's 2 ways to do it. You can think centi is a -2, or you can think a century's got 100 years. So there's 100 centimeters inside 1 meter. So to get out of the centi, the math that we always do there is divide by 100. So if I by 10 divide by 100, that number is going to give me 0.02 meters. So 0.02 meters. So now if I want to calculate what is that work done, I take my force, which is measured in newtons, and I multiply by my distance, which has to be the meters, which is my 0.02. And you should use a calculator. So what we're going to do is our force, which is 5, we're going to multiply by 0.02, because we have to divide by 10, divide by 100 to get into meters. And we'll get a number then of 0.1 joules. 0.1 joules. Okay, what about this? What about now if I have a box, it's moved with a force of 10 newtons in the upward direction, but let's say the box moves to the right 6 meters. It says, what is the work done? How do we calculate the work done? So the force is going upwards, let's say towards the north, and the box is moving towards the right. So in this direction, the box is moving in that direction, which is, let's say, the east. Because these are not parallel lines, do you see? These are actually perpendicular lines. They're at right angles to each other. So because they're perpendicular to each other, the force might be 10 newtons, because work done is force times distance. The force is 10 newtons, but we don't move any distance in that direction. We move 0 distance in that direction. So the work done is 0 joules, okay? So again, if they're not parallel to each other, remember we said they had to be parallel, there is no work done on this box. Same thing if I think about, let's say I had this board and I pushed the board with all of my force. And the question is, did you do any work? So I'm pushing the board with all of my force, but it's not moving. So when I go to calculate the work done, even though I push it with all of my force, maybe I push it with 1,000 newtons if I'm super strong, because the distance it moves is 0, the work I do is 0 joules. Okay? So if it doesn't move, I don't do any work. Let's say we've got a question where we're told that the work done is 60 joules. They do 60 joules of work to move a box, I don't know, let's say 5 meters. And we want to calculate the force. Okay? So I want to know what is the force that they used to move that box. I know my equation. When I see work done, I always put in as a force times a distance. It told me what the work is, because work is always measured in joules. It told me the work is 60 equals some force times by the distance, which is 5. If I want to get the force by itself, I think, what's the opposite of multiplying by 5 to get rid of it? The opposite of multiplying 5 is divide by 5. And what we do to one side, we have to do the other. So I do 60 divided by 5, and that should be 12, but let's just double check our calculator because we have one. 60 divided by 5 gives me 12. And then final answer is forces are always measured in newtons, 12 newtons, okay? So key things is, remember that the force and the distance has to be in the same direction, right? They'll be parallel lines. And if they're at right angles to each other, there's no work done because there's box is not moved any distance in that same direction as the force. Or if we put as much force as we can, as much force I can on this board, but it doesn't move, I'm not doing any work, 0 joules. So hopefully you find this video useful. If you did, just remember to subscribe.